Hey, welcome back. Circumstances warrant that I do something short and sweet today. Let's just do that and solve some Sudoku puzzles. Hey Ravi,
Hey, okay.
you play Sudoku, right?
I used to when it came out. Now I'm more of a chess guy.
Oh, okay.
What about you?
Yeah, I mean, more than me, my wife used to play Sudoku a lot.
Right.
So this episode will be for her.
Dedication to
speak.
Shilpa.
Yeah.
Okay. So you're going to make a Sudoku? What are you going to do this?
So I've always wanted to have the computer solve it all by itself.
Right.
So we're going to use our very famous backtracking algorithm,
Oh.
backtracking recursion to
Ah.
solve a Sudoku
Oh,
board. All right. So
okay.
given a Sudoku
Right.
puzzle,
Ah.
we'll have the computer solve it.
Oh, so maybe I can also do a small dedication here. One of my friends from college, he got married, and as soon as he got married, he had to come to Chennai for that US consulate interview, right? So these are like really newly weds. And so my mom was solving Sudoku, and this guy wanted to show off to his wife. So he said, I'm going to write a Sudoku solving problems and program and all. I think he managed to do it in the end, but not like immediately.
Oh.
So let's see, RK, if your program can solve it.
But before we even go there, let's all get on the same page as to what Sudoku is and what constitutes a solved Sudoku.
Sure.
All right. So what I'm showing over here is a typical Sudoku grid. This is actually a Sudoku problem that I took from one of those Sudoku of the day websites. All right, and we'll work with just this one. And if the viewers are interested, they might just change the values of the grid, and they can see different solutions for different Sudokus.
Makes sense.
All right. So the goal of Sudoku is to enter all numbers from 1 to 9 on all of the grid values over here, or all of the cells here. All right. The conditions are that each row should only have values from 1 to 9. Each column should have a value from 1 to 9. And each 3x3 cell or 3x3 grid itself should only have values from 1 to 9.
So occurring exactly once.
Exactly once. So what I have done over here is that I've just marked this grid, and we are going to try and fill a value over here.
Sure.
Let's fill this with the value 2, for example. So let's check if it is possible to place a cell on row 2, right?
Yeah.
I mean, let's do this. This is row 2,
Correct.
and this is column 5.
Yes.
So I've marked the rows and the columns, and I've also marked the big cells also, right? So this 3x3 grid also I've marked it. So that's 0, 1, 2 and 0, 1, 2.
Nice.
That's what it essentially signifies. So can I place the number 2 over here? Now let's check. So this is 0 to...
Yeah.
So 2 doesn't exist already on this row. So that's possible.
Right.
Does 2 exist over here?
No. So now it's
so 2 is possible. But does 2 exist over here?
No.
So that's possible. So if you look at the answers, so yes, 2 is a possible combination or is a possible
candidate.
Number here. Candidate. Let's place 8 over here. Once again, it passes the first 2 tests because there is no 8 on this row. There is no 8 on the 5th row, but there is an 8 already on this grid. So that's why 8 doesn't become possible. Now, keeping that in mind, let's try and look at some pseudocode for what a
Pseudocode.
For a Sudoku solver.
Right.
Good catch, man. Even I didn't think of that. All right, let's get started. I already have a HTML page in place. The head of which includes the Sudoku solver.js file. It has a proper title, and then I have a body on which a canvas is placed in the center of the page. Now the onload of the body calls out to an init function which is on the Sudoku solver.js, which is declared over here. It fetches the canvas element from the document elements, resizes the canvas if it is necessary to accommodate mobile and smaller devices, fetches the context from the canvas, and sets the width and the height. Now the width, height, and the context are all global variables declared in the JavaScript file. All right, to get started with our Sudoku solver, we first need to draw the Sudoku puzzle onto the canvas. I already have a grid in place, which has the Sudoku puzzle in place. Now the grid has 0 in place where the value should be blank. So zeros would be rendered as blank on the canvas, whereas the numbers would be rendered as they are onto the screen. All right, with that being said, let's just go ahead and render them on the screen first. So I'm declaring some variables over here that will be used to render the grid on the canvas. Now, whatever I'm rendering needs to be proportional to the size of the canvas. That is the purpose of the code that I'm writing here. So the font size is proportional to the width of the canvas. So we'll make the context font the size or that proportional size. We'll also initialize the values of the X and the Y text offset. So this would be used to render the text a little bit offset on the screen. So here is me declaring the render Sudoku grid function, and we need to draw the thin lines as well as the thick lines. So this is where the thin lines are being drawn. These thin lines would be the inner grid, or the smaller grids of the larger 9x9 grid. I think this is pretty straightforward to understand. And here is the thicker grid being drawn. All right, so that would be the size of, every 3 cells of the inner grid would be one big outer grid. All right, so once we have that, we also have to render the numbers on the screen. And all right, so once we've done that, all we need is like 2 for loops to go through the grid and render all of them at specific locations on the grid. And this is where the offsets are being used. And once the offsets are used, we can use the fill text to fill them on the screen. All right, let's look at what that looks like. When I hit refresh, you can see that the Sudoku grid that we had as a double dimensional array is represented properly as a grid. Now, technically speaking, this should scale up properly with the size of the canvas as well. So if you're watching this on a mobile, it should scale properly. Now, 0 values are of course not rendered on the screen because of this condition that we put on the screen. All right, now the X and Y positions are calculated, and then the number on the grid is painted on the screen using the fill text, and this is what it looks like. All right, now let's get on to the 2 most important parts of a Sudoku solver. The first part is to check if it is possible to place a number at a specific place, and the second part is to actually write the backtracking recursion algorithm. We'll start writing a function that will check if it is possible to put a number at a specific location on the grid. So if I wanted to place a number here, then I'll have to check if it is possible to place that number on the row. Then I'll check if it is possible to place that number on the column. And then I'll check if it is possible to place that number on the mini grid within the larger grid itself. So those are the 3 checks that we'll have to perform in our function to check if a number can be placed at a specific location. So let's get writing to that. We'll call this function isPossible, and it will take 3 parameters. I think they're pretty straightforward. We'll first check if it is possible to place the values on the rows. So this is us checking if it's possible to place the value n on any of the rows. And we'll do the same thing for the columns as well. Next, wherever that cell belongs to, or whichever 3x3 grid that cell belongs to, we check that specific grid. All right, so that's what is happening over here. So we are checking if it's possible to place the value in that smaller grid within the larger Sudoku puzzle. All right, now that we have written the isPossible method, it's actually possible to test if this method works without having to write the algorithm, the backtracking algorithm first. So I have the grid loaded over here, I have the canvas loaded, and I also have the console loaded. Now let's check if it's possible to place the number 1 at the first cell on the grid. All right, so that would be 0, 0, right? So I can just say is possible 0, 0, and what number did we want to place? We wanted to place the number 1. And you will see that it returns false. That's because 1 already exists here. And 1 also exists over here. What about the number 9? Is it possible? No. Why? Because there is a number 9 here. All right. What about the number 3? All right. It's still not possible because the small cell over here contains a 3. All right. Now let's look at number 6, for example. And if you look at it, number 6 returns a true. And the reason for that is because there's no 6 here, there is no 6 here, and there is no 6 within the smaller grid. Now let's take a different cell on this grid and see if it's possible to place a number there. For the sake of convenience, I'm going to choose the center grid, which I think is 4 by 4. And let's see what are the possibilities of, so I'll say is possible 4, 4. Let's see if 1 is possible. And it says that it's true, which is correct because there is no 1 on this place, there is no 1 here, and there is no 1 here as well. Let's take another number. Let's take 3, for example. 3 is not possible because there is no 3 here. Of course, there is no 3 here, but 3 is in the smaller grid. So, let's take 9. And yeah, of course, 9 is not possible because it's here. So now we know that the is possible works. Now let's get to writing the backtracking recursion algorithm. Let's look at the backtracking algorithm. The name of our function would be called solve, and its job would be to go through every cell in the grid and check if it is possible to place a number n. All right, it will go through every possible number from 1 to 9 that can be placed on the grid, and it will check if it is possible to place that number on that grid. Now, if it is possible to place it, then it will assign the value n to that cell on the grid. And then using recursion, it will just simply call the solve function. Now what will happen here is that the grid function would have a number n, it would assign a value, and then it would simply move on, not from the next cell onwards, but it will start right from the beginning. So at this point, what will happen is that, it looks very straightforward. So let me just show you the sheet. So let's say we start with this. At the very first instance of this recursion, it'll pick a number which is possible and it will place it. So the grid now has the value 6. Then it moves on, basically recurses, and goes back to the beginning and sees if it is possible to place the number 9. Right? So it's not just selecting 9, but it's going through all the values 0 to 9. And whichever number is possible to be placed over here, it will place it there. That's because we have the is possible function call over here. Now once that happens, then the grid is set to that value. So it goes on and on until it can fill all of the values. However, if it finds that, let's say it gets to this position and it is not able to fill or find any values that can be placed over here, then that's where the beauty of the backtracking algorithm comes into play. It goes back to the previous number where it was possible, or where it was possible to put some other number, and then it will start from there. So if it came to, let's say 0, 2 row, this is the 1, 4 row. It came here and it did not find a number. If the is possible did not return anything, then it simply backtracks to where the last number was possible and tries from there. That's what the grid equal to 0 does right after the solve. So at the end of this for loop, this grid would be solved. All right. So let's just convert this into code and see what it looks like. The good thing about having a pseudocode is that all I have to do now is convert that pseudocode into JavaScript code, which is very straightforward. We go through every element of the grid and check if it's possible to be placed on the grid, and then place that value if it is possible. Now remember, at the end of this function, I'll have to ensure that I call the render Sudoku grid so that the solved values are visible on the screen itself. All right, so let's just copy this, paste it here, and we're done. Let's look at what that looks like, shall we? Now remember that I haven't invoked this function solve from anywhere. It needs to be called from somewhere, and therefore what I've done is that I have called the solve function from the on click of the canvas itself. So if the canvas is clicked, then the on click, then the solve will be called. All right, so let's see what that looks like. Let me refresh the screen once, and bang! We didn't expect it to be that fast, right? All right, so this is actually a solved Sudoku puzzle. All right, so that whole recursion thing went in so fast that it actually went ahead and solved it so fast. Now we are using JavaScript over here, and if you've been with our channel for a very long time, you know that you expect this to be animated, right? So let's just play around with this just a little bit and animate this. I'll declare a variable over here called origGrid, which will be the original grid, and it'll have the original values of the grid itself. I also have a variable called answerGrid that will have the answer itself. I've replaced every instance of the grid with the origGrid, and at the end of the solve method, I'll copy the values from the origGrid into the answerGrid. I'm going to call a function over here called animate Sudoku solution, and its job is to take a random value from the answer grid and then assign it to the grid itself. Every time it assigns a value to the grid, it will render it on the screen. All right, so here is us assigning the answer grid onto the grid, and then we'll just call the render Sudoku grid. And of course, we cannot have it run forever, or else this loop will never end. So we'll have to check if the grid itself is complete, or if we have filled in all the values. And once we have done that, we are done. Let's look at the result of that. When I click on the canvas, it starts placing the values in the cells slowly, giving it the illusion that the number is being solved when it appears on the screen. But you and I both know that's not true. The Sudoku puzzle was solved in under a millisecond, or maybe it just took a few milliseconds. It's just that the numbers were placed slowly. Let's look at the result with Ravi now, shall we? You ready to look at the results?
Sure.
Clicky. So although it looks like it's putting one number by one number, the solution was actually got in less than a second. It's just that using the power of JavaScript, or using the magic of JavaScript, I'm just putting one letter by one letter on the screen randomly.
Okay, so you animated just for the sake of it looking nice.
Yeah,
it does look nice.
It does look nice. Yeah.
As if I'm actually solving one by one.
Exactly. As if the computer is thinking about it and placing the numbers. Now I'm using the same grid over and over again without these numbers.
With the same numbers.
Yes, but viewers can actually go ahead, change these numbers on the JavaScript source, and then
try out different
possibilities. Try out different things. So here goes, it's the same thing, but it's filled in a different order. It's filled in a random order. All right. So that's about it that I had for this week.
Yeah.
So we'll circle back next week. Hopefully I get my laptop back and I get to solving that ants problem.
Sure.
All right.
Thank
you very much for joining. What did you think of this episode? Leave a comment below and subscribe if you haven't already. Bye.
Ciao.